So welcome back, Stira. I'm going to show you the second method of doing this integral. This method I will show you, this is an integral. Basically, I forgot to tell you that this is an integral that has already come at Polytechnic Concours. I think it was 2013. Yes, I think the integral was not having boundaries. Yes, it was an indefinite integral, but it's almost the same integral. It came at Polytechnic entrance examination. I think it's 2013, if I can recall things very well. Now, the method, as I said, this second method I'll show to you. It is not a method that applies everywhere. Be very careful. It is a method we had a chance will pass in this we can easily apply that method in finding this integral. You understand? So how does the method goes about? Our aim is to find the integral from 0 to pi on 4 of what? Sine theta all over sine theta plus cos theta d theta. We have to prove that it is equals to this. Now, what I will do is what? I'll call this integral that I'm finding, I'll call it capital I. I'll call it capital I. That is, let capital I to be equals to what? The integral from 0 to pi on 4 of what? Sine theta all over what? Sine theta plus cos theta. There is d theta here that I forgot. D theta. Is that okay? Now, as I said, we let our capital I to be the integral we are looking for. Now, look at something. At the bottom of this integral, there is cos theta. You understand? So, I will let j to be what? J, capital J, to be equals to the integral from 0 to pi on 4 of this cos theta. Because for this I, there is sine theta on top. Now, for j, I will let j to be equals to the integral from 0 to pi on 4 of what? Cos theta all over sine theta plus cos theta d theta. You understand what I'm doing, why I'm doing that. Now, after letting these two integrals, what I will do is what? I will find I plus j and I will find I minus j. You can decide to find j minus I, depends on you. Let's calculate I plus j. When I do I plus j, this capital I plus this capital J, it's simply this integral of sine theta all over sine theta plus cos theta from 0 to pi on 4 plus what? This other integral of cos theta all over sine theta plus cos theta d theta. Is that okay? Now, look at these two integrals. They are, what is common? They have the same denominator. This term, the term here has the same denominator. The denominator here is sine theta plus cos theta. The denominator here is sine theta plus cos theta. And the boundaries of integration are the same. There is an important rule in integration. The integral from a to b of f of x plus g of x is equals dx is equals to what? The integral from a to b of f of x dx plus the integral from a to b of g of x dx. Is that okay? So the boundaries of integration here are the same. So this integral, these two integrals becomes what? Integral from 0 to pi on 4 of what? Sine theta all over sine theta plus cos theta plus what? There is d theta here. No, let me put the d theta outside. Plus cos theta all over sine theta plus cos theta with d theta outside. Is that okay? We are just applying this property. Is that okay? Now, this has the same denominator as this. So this integral becomes equals to what? Integral from 0 to pi on 4 of what? Sine theta plus cos theta all over sine theta plus cos theta d theta. Is that okay? Is that okay? So I hope you understood how this I plus j became this. Is that okay? Perfect. Okay, perfect. Now, you see that this sine theta plus cos theta is common down here. So this will cancel this, and we'll be left with what? I plus j will be equals to what? Integral from 0 to pi on 4 of what? D theta. Is that okay? When we integrate d theta, we have what? Theta with boundaries going from what? 0 to pi on 4. Is that okay? So when I replace here, I will have the upper bound minus what? The lower bound. So I will have I plus j being equals to what? Pi on 4 minus 0. This implies I plus j will be equals to what? Pi on 4. Is that okay? So that's why I have I plus j being equals to pi on 4. That's my first equation. That's my first equation. The next thing we said we should calculate also what? I minus j. Is that okay? So let's now calculate I minus j. I minus j, our I integral is this, and our j integral is this. So I minus j will be this integral from 0 to pi on 4 sine theta all over sine theta plus cos theta minus what? Integral from 0 to pi on 4 of cos theta all over sine theta plus cos theta d theta. Is that okay? Now I will do the same thing. I will apply this property. So since the boundaries of integration are identical here, this will become what? It will become integral from 0 to pi on 4 of what? Of sine theta all over sine theta plus cos theta minus what? Cos theta all over sine theta plus cos theta, all that d theta, because d theta is common here. Is that okay? From there, I'll combine these two and this will give me this. Is that okay? So that's how I went about to have I minus j to be equals to this. Is that okay? Now, our aim is to calculate what? This integral from 0 to pi on 4 of what? Sine theta minus cos theta all over sine theta plus cos theta. But notice something. We notice that d of the denominator is equals to what? When I differentiate the denominator, I have cos theta minus sine theta. Is that okay? What do you notice? We notice that the difference between this cos theta minus sine theta and times d theta with this bottom sine theta minus cos theta times this theta is what? If we multiply, we notice that this d of sine theta plus cos theta, it is the same thing as what? If I factorize minus 1 here, I will have minus sine theta minus cos theta d of theta. That means for this to resemble, for this top to resemble this, I have to multiply this integral top and bottom by what? Minus 1. So that's why I wrote 1 minus j being equals to minus 1 times minus 1, minus 1 over minus 1 integral from 0 to pi on 4 of this all over this d theta. Now, this, look at something. This minus, this first minus will enter here and it will become cos theta minus sine theta d theta. Is that okay? And the other minus will stay outside. Is that okay? Perfect. Let's continue. Now we have this. We notice something. This d of sine theta plus cos theta was equals to what? Was equals to minus sine theta cos theta, which is cos theta minus sine theta. So all what is on top here, we shall replace it by what? D of sine theta plus cos theta. That's what I did here. Now, this integral is simply like you are integrating d of a big X all over a big X. So that will give minus, this minus is outside, we put the brackets. This integral will give us ln of the absolute value of what? Sine theta plus cos theta, with boundaries going from what? 0 to pi on 4, 0 to pi on 4. Now, we're going to do the upper bound minus the lower bound. Don't forget there's a minus outside. I'll put my bracket. The upper bound, I replace the upper bound. So I'll have ln of the absolute value of sine pi on 4 plus cos pi on 4 minus the sine minus, yes, minus ln of the absolute value of what? Sine 0 plus cos 0. I replace the lower bound. Now, sine of 0 is 0, cos of 0 is 1. And we are going to have here the absolute value of 1. Sine pi on 4 is root 2 on 2, and cos pi on 4 is what? Root 2 on 2. Is that okay? So we'll be left with this. Ln of absolute value of 1 is 1, ln of 1 is 0. Here we're going to have 2 root 2 all over 2. So we are left with what? Minus into what? Ln of root 2. But we know that this root 2 can be written as 2 to the half. So this half, first of all, absolute value of root 2 is root 2. You understand? So this 2, we know that the absolute value of root 2 is equals to root 2. Is that okay? Now, this root 2 can be written as 2 to the half. So that's why I wrote it here. Is that okay? It will then come out and I will be left with what? I minus j being equals to what? Minus half plus ln 2. So this is our second equation. Now, we have our first equation, I plus j, which is equals to what? Which was equals to what? Pi on 4. Our second equation is what? I minus j, which is equals to what? Minus ln of 2. What do you then have to do? What was the integral we were looking for? Now, look at something. This is the system of two equations we have to solve. What were we asked to find in this question? We were asked to find this integral. And how did we call this integral? This integral was called what? I. That means when we shall solve that system of equation, and we'll get I, we will have gotten what? This integral. Is that okay? So, where is the system of equation? This is the system of equation. For me to have I just make equation 1 plus equation 2. That will eliminate G. Is that okay? So, equation 1 plus equation 2, I will have what? 2I being equals to what? This plus this. So, pi on 4 minus a half ln of 2. When I divide all through by 2, I will have what? I being equals to what? Pi on 8 minus what? 1/4 ln of 2. But recall that what? I was equals to what? Which integral? Integral from 0 to pi on 4 of sine theta all over sine theta plus cos theta d theta. So we have proved that what? The integral from 0 to pi on 4 of sine theta all over sine theta plus cos theta d theta, which we called I, is equals to what? Pi on 8 minus 1/4 ln 2. Take note of this other approach. I said this approach does not work anywhere. If you take note of this question, what made me to use this approach was what? I knew that if I call a j another integral where there is this cos is found on top here, when I will be adding them, they will cancel out and I will be left with a calculation here. Is that okay? So always look, when you have integrals of this one, you look for an integral that when you will add to this integral, they will cancel out to leave what? To give 1 here, and it will be easy to integrate. So basically, you come out with systems of equations that you solve and it will give you the answer. This is a question that came in Polytechnic, as I was saying. The entrance examination into Polytechnic, I think is in 2013. Yes, if I can remember, in 2013. So take note of this other approach I gave to you. Take note of this approach. So that will be the end for this video. In the next video, I'm going to do which exercise? We have proven already this. We are going to do this one. We are going to do this integral. In this integral, there was also an error. The answer here is minus pi on 3. So we are going to prove this integral. We are going to prove this integral in the next video. Is that okay? We shall look at this integral. So see you in the next video for us to do this question. Is that okay? So go through all the videos, all the previous videos, and try to master all the secrets I gave to you. So see you in the next video.